2, oh fuck, 1, go. You are live.
Hello. Hi, everybody. Hi, everybody on YouTube and everybody on Zoom. Just checking here if it works. Yes, it works. Okay, for the ones who don't know me, my name is Milen. Nice to meet you. I'm the manager of this wonderful class who's presenting today in Rio de Janeiro. But before we start, I know you're not here for that, but before we start, let me just present to you Wagon. And also, like, who are these people? Like, what did they do the last 9 weeks? So for the ones who don't know, we're here today for the presentation of class 1144, which is data science class. And today is the final day of their bootcamp. They have been learning for the past 9 weeks about data science, data analytics, data visualization, Python, deep learning, machine learning, and they've implemented some of these methods in their final project. And this is what you're gonna see tonight. It's beautiful people. But before that, let me just tell you a little bit more about Wagon. We're simply the #1 coding bootcamp worldwide. And perhaps you don't know that we also have almost 20,000 students all around the world who graduated in more than 45 cities. So it's not only a really cool school, it's also a very international school. And you can see it in this class where we have many different nationalities. And we're very famous for two formats, two bootcamps. The first one is web development, where we teach people how to become a developer in just 9 weeks. And second one is data science, is the one you're gonna see tonight. Most of them were not beginners once they started, like they had some prerequisites in math and programming, but they were all beginners in data science, machine learning, deep learning, like all the things they've learned from the bootcamp. So please be impressed by the result, because that's the result of a hard work, a lot of new knowledge for them. And they were just beginners in this knowledge just a few weeks ago. So please be impressed. And perhaps you don't know it yet, but we'll offer these two bootcamp in two formats. The first one is full-time. So like the class we're gonna see today, they have been working every single day, Monday to Friday, the whole day for 9 weeks. And the part-time formats, it's the same thing, it's the same amount of hours, teachers, exercise, instead of it's during 6 months, Tuesday and Thursday night, and Saturday the whole day. And something new that is coming this April, it's a new bootcamp. The first time we have a new bootcamp in 2 years, so I'm really excited about this one. It's about data analytics, and this one is for beginners. So unlike data science, which we ask for some coding basics and math and statistics, algebra, data analysis doesn't have any prerequisites. Like you can be a complete beginner, and we can make a data analyst out of you in just 9 weeks. 9 weeks is still 400 hours, so it's still a lot of content. But now we can move on to the fantastic class of today, class 1144. What kind of class is 1144? It was a carnival class, the class that celebrated over a long weekend. The carnival is the only bootcamp in the world that has a long weekends to celebrate. Also the class of fine dining. As you can see, our Carioca students took our international students to the best places in Rio, Frontera, Calisvero. Great experience for our students. Also special mention to Jonathan, the best Carioca award. They also worked. I still want to put some pictures of you working, because you also worked hard. Sometimes, most of the times you were working. That's the only picture we have of Marcel smiling, by the way. So this is a collector picture that I really wanted to highlight. But now, are you ready to move on to the real deal of today? Show the data. And for the first group, I will be calling Jonathan from Electroprofit. Are you ready, Jonathan?
Yes, I'm ready. I just start by sharing my screen.
Okay.
Can you
see your
my
screen.
screen now?
Yeah.
So hi everyone, I'm Jonathan. I'm from France, and today I'm presenting to you the project Electroprofit. Did you know that 34,000 tons of carbon dioxide is being produced every year because of electricity production? It's coming from burning oil, burning gas, and burning coal. So trust me, you don't want to risk that. To help to reduce this problem, we have been working on Electroprofit. During the last 9 weeks, I have been working with Tobias, Caio, and Marcel to build a useful product. To build a product that could help people to reduce their carbon footprint when using electricity. So we are very proud to show you our project, ElectroProfet. ElectroProfet is a deep learning model that predicts the production of low-carbon electricity and informs users when they should use electricity during the day in order to minimize their carbon footprint. These projects run in the context of reduction of carbon emissions to fit with the global agreement, like the Paris Agreement on climate change, who says us to keep the global warming under 1.5 degrees since the pre-industrial levels. The carbon footprint of electricity production is fluctuating during the day regarding to how the electricity is produced and consumed. We can produce electricity by two different ways: by dirty energies when we burn coal, gas, or oil, and also by low carbon energies with solar, wind turbine, hydraulic, and also nuclear energy. In the case of France, electricity is produced in majority with nuclear plants and also oftenly with gas, oil, and coal when the demand is high, as you can see here. For example, on this graph, you can see the red parts with only gas power. So, depending on the weather conditions, if tomorrow is sunny or windy, the question we want to solve is how much green energy can we produce in the country? And also, on what time electricity will be produced at low carbon? Our deep learning algorithm want to help to predict this electricity production. Can you hear me?
Now, yes, now, yes.
So we have been designing a technical solution. First, we get data from 4 different sources: the weather forecast for the next 24 hours, the weather history from the last 3 years, but also the electricity production from the last 3 years, as well as the electricity consumption for France here. Then our deep learning model predicts electricity production from the wind, electricity production from the sun, and electricity consumption. And finally, we compute our hourly recommendations and display icons for the user, as you can see here on this mobile phone. But now, let's try a live demo. So the question is, when should I use electricity in the next hours and switch on my washing machine, for example? So let's move to our prototype here. So here I type a city. So our model was running for Hauts-de-France, so the north region of France. So let's type a city like Lille for us. Now, as you can see, it's running, biking, and everything, because there is a lot of data that we have to compute. So now we are doing some prediction and recommendation for this city. We choose, for example, Lille. Just let's wait for the algorithm to compute. It takes normally about something like 1 minute. So now we get our data from different data sets, and the prototype is ready to run the predictions. Run the predictions. So when we got our data set, we worked on some preprocessing steps and featured extraction, scaling, and selection before to compute our algorithm and tune our model until we display our best recommendation. As a reminder, this model is quite complex because we fetch 1 data point for every hour of production and consumption for the last 3 years. So it takes time to compute, but it's normal. and see our results. So we have 24 faces for the next 24 hours, and our program is able to tell to the user that you can wait, for example, to 22 hours. This is the French time. So if you want to switch on your washing machine, please wait 1 hour. Let's go back. To the presentation. So we have 3 kinds of faces: happy, neutral, and unhappy. We have nevertheless some improvements of our work, and we can improve electricity production to the whole country. Also, we can upgrade electricity production to all types of energy, like oil, gas, coal, nuclear, and hydraulic, and compute the carbon footprint of the electricity mix to improve our recommendations to the user. I hope you enjoyed this demonstration, and thanks for watching.
Yay! More! Woo!
I don't know if you can see anything.
There's a lot of people.
We get money.
Congratulations, team. Great work. We know it's a lot of data being processed, so no worries. It's already very fast. Okie dokie. Already moving on to the next project. I will be calling Caio and Arthur for learning from time-lapse imagery. Are you guys ready?
Yes.
It's working.
So, can we start?
Yeah.
Okay. So, the name of our project is Learning from Imagery. Actually, we as a group, we had an interest of going a little bit deeper on the models that were taught to us in class about images, and more specifically, we would like to do something with image recognition and computer vision. Well, but why to do that? Besides a simple interest, there is a growing demand nowadays for these kinds of models. You have a lot of applications of it, you know. You have applications. A very common example is the technology that enable cars to drive themselves alone. And we also have some applications in the medical fields. And well, besides that, there are a lot of other applications. So we wanted to go a little bit deep on that. And we did. And then just moving on to our more specific objective. It's a broad field. So what did we choose to do? Actually, we chose to do something related to counting objects in pictures. And the object that was chosen by us was penguins. But why penguins? It's such a strange thing, besides being fluffy animals. And actually, we chose that because there are some studies that require this type of technology. There are biological areas. Sorry, you have studies that study the development of colonies of penguins, and in order to do that, we needed a very big data set in order to train our model to be able to detect penguins. So, just going a little bit over our data set, we found a data set from this link over here that contained over 80,000 images of colonies of penguins that they put fixed cameras and they took images of it, you know, hour by hour, just in a good resolution, of course. And so we could study the evolvement of it. And well, out of these 80,000 images, because there is a lot to process, we chose 5,000 pictures, and then we just moved on. And we just trained our models. Something I forgot. I'm sorry. These images, they were accompanied by annotations. What were these annotations? They were with a lot of volunteers that pinpointed the penguins. So they manually counted the penguins, and then we got label data. And well, this approach of the label data, there were some problems with it, but Artur will be able to explain it a little bit better. But after we can do some metrics with it and some things like that. Well, now I'll give the word to Artur, and please, Artur, feel free.
Thank you, Caio. So just as Caio said, computer vision is a big, wide field with a lot of different problems, and it has been developing in terms of how to approach each problem. So you have things starting off just as semantic segmentation, which is just categorizing every part of the image, a single object to identify where it is and what kind of object it is. And the one we have is multiple objects. So you have object detection of a category and also locating it inside of the image. It has been evolving a lot in the past few years. So this is a competition that has been done in the United States. So trying out different models for the past few years. And you can see that the score of the models has been getting a lot higher. Over here is the loss. So how much the model gets it wrong. So one of the differences is that images, you need a big data sets, like the one we're dealing with. And one of the big changes was the computational power of machines, and also being able to apply this different way of solving different model, which is convolutional networks. And what it is it actually uses a lot of layers to modify the images and get different sets of features of an image, and dealing with these complex problems, and has been evolving a lot in the past few years. Every year we have different and new ways of approaching problems, and it's very interesting. That is why we were very interested about dealing with it. So in a nutshell, it kind of our problem, which is detecting objects, resumes in you can summarize it in just two different kinds of things the model can do, right? So it takes an image that has a box that says where the object is, and it's going to train understanding the features of this box, and it tries out different regions of the image to classify whether it is a category, an object or not. So we have to deal and say, with this each box that is tried out, is it an object, or is it a background? And propose new regions in terms of very efficient ways to deal with these big problems and making them smaller. So one of the latest advancements we've had is the development of faster RCNN, which is a model that, as you can see in the graph, it trains a lot faster in different models, and also is used to predict. So you can fit it in cell phones, and you can set it in different devices that don't have as much power. So it gives a lot broader way of applying those models. So our workflow was mainly these 4 stages. So pre-process our images, estimate the bounding boxes, train the model parameters, and evaluate and fine-tune the models in each, to see what results we have and how can we make it better in terms of predictions. So the biggest thing was estimating bounding boxes. What are the bounding boxes? Is the ground truth that the model is going to use to see which features we have to learn. So where is the object and how does it differentiate from the background? So as Caio said, we had a little bit of problem with this, because one of the big things about dealing with images, you need it's very expensive to get a data set in terms of marking where the objects are faithfully to the image. And what we had was different volunteers putting dots, dot annotations in the image. So at first we tried out by getting all these points together and then making the bounding boxes by offsets. As you can see, it didn't work out that well in terms of there are some penguins that are in the foreground, some of them in the background. So it makes it harder for the model to understand what the penguins are, where the penguins are, and what their features are. So we tried to solve it by using another model, an unsupervised model, to see where the penguins are. As you can see, it's a lot better in terms of defining where the penguins are and how the model can learn about its features in an image. And then we applied the model, as you're going to see right now. We trained it with our images. And over here is our application where we can get the predictions of where the penguins are. These are a couple of images. At first, we're going to check it if I can do it in an image that we used in our own data set to see how it performs. So this is the image. It's going to try to process with all the parameters are already trained. So it's going to just predict them. Over here, we can see each purple name is a penguin and the box is in green. So you can see it identified a lot of penguins over here. It seems to be a pretty good model. It's a lot better than the one we had with the annotation boxes. And now what we can do is actually apply it to a different set of images. That is not the ones that we trained, because it's more faithful to see if the model is actually working well. And as you can see, it has some penguins over here that are online, a little bit more difficult for the model to assess. But over here in the left and the right side, it has a very good accuracy in terms of detecting new images. Over here is one at the beach. So we can see this one, actually things are a lot clearer and the penguins are a little bit darker. So it gets a lot better results in terms of identifying the penguins. So what can we do? We developed this model. We have the annotation problems, but this brings me back to limitations, next steps. As I said, the big thing about working with images is that we work with big data sets, and you need a lot of processing power to actually train the model a lot. So to get the unsupervised, we trained with just 5,000 out of 80,000 data set. So with just 5,000, we took 5 hours to train and get the inputs, so outputs of the unsupervised model, which would be our inputs for the second model. And it took 12 hours to train just once our model to get the actual training that you're seeing today. So there are a lot of things that we could try out in terms of learning rate, training data sets, using the whole data set, trying out different models, but we were limited in terms of computational power and also time. But there are also a lot of steps that you can take to make the model even better than it already is. So thank you. That was our presentation. I hope you liked it, and I'll be here.
Yay!
Congratulations.
Woo!
I hope you can feel the vibe from there. Congratulations, team. Congratulations. Cute in the chat. Okie dokie. I hope seeing all these penguins made you want to travel, because for the next speech, we're gonna travel. We're gonna go on a road trip with Manon. Are you ready, Manon?
Yes, I'm ready.
Don't forget to put your camera on.
So welcome to our road trip planner. So basically, we found that there are problems when creating road trips. So there are many pains, such as time consumption. So for example, when making research about a country, finding things to do, places to sleep or eat, or even mapping routes, is all very complicated. And all of this information is scattered across many websites, forums, blogs, and social media. So it can take a lot of time to find the right information and condense them. So we found a way by computing it. So the methodology is that we use all of our data. So first of all, with the Places API, we use match visit in a country, so sorted by ratings. There's the tourist attractions, landmarks, natural features, and national parks. Then we use the Maps API to input these places as markers for the one-way trip and waypoints for round trip. I'll explain this later. And we use the cities, so the cities where the user can stop and we input these every X kilometers that are computed based on the user inputs.
We can't hear it anymore.
And some calculations. And lastly, based on okay. So the trip in a city and finishes in a different location. So this program also allows the user to cross many countries. So we need 3 user inputs: the start location, the hours to drive per day, and end location. Then we calculate the max distance per day that the user can travel. And thanks to this distance, we split the routes by finding nearby cities, and the cities will define the waypoints coordinates, so we can add them as markers on the map. And for each city, our code will find the best rated hotels and restaurants, and also add those as markers. And lastly, we add all the natural features, tourist attractions, national parks, and famous landmarks as markers for each country's cross-strait trip. So this is an example in our app. So here the user will input the origin, the destination, how many hours he's willing to drive per day. And this is, for example, from Lisbon to Barcelona. And it will create a route with many cities where you can stop. So the map is interactive. You can click on the cities. There's the restaurant layer and all of these markers or the landmarks you can visit. We also have some pictures of other options. So here, for example, it's within Spain, here in Japan, so this is a bigger trip. And here it crosses, for example, from Paris to Berlin, and so we can see it crosses many cities and still gives recommendations. Then we had to compute the round trip. So this is the feature that would find the road if the user is leaving and returning to the same place. So our method is slightly different here from the one-way trip, because here the user inputs a start location, the duration for the trip, and the hours he's willing to drive per day. Based on this input, we will calculate a radius that will allow us to select 24 waypoints from all attractions within the radius at random. This 24 is because there's a limit at Google API on how many waypoints you can put on a map. So that's why these need to be selected at random. And the rest of the attraction within the radius that are not selected as waypoints will be seen as markers as well. Then we compute an optimized route that will go through all the selected waypoints, and similarly to the one-way trip, find cities nearby the route where the user will be able to stop and select best hotels and restaurants. And this will create a map. So unfortunately, this takes a lot of time here to compute. So we had to take screenshots beforehand because this would take 10 minutes approximately. So here are some examples. So this is a round trip in Switzerland. We can see that it's an interactive map, so you can click on the markers that have different colors and so you have 2 places to visit: restaurants, cities, and hotels. This is in Japan, Iceland, and the UK. So this is a bigger road trip. All of these have been created using the user inputs. Then we have also created another feature. So which will allow users to discover the must-do attractions in a country, state, or city. And this can be useful for users that are only visiting one city or city hopping using public transports or just curious about a place. So this will be here in the destination attractions. It also takes a long time to charge. So we have it here. We'll take this form, so you can input your city, and it will put markers on all the places you want to visit. And it's also an interactive map, as well as a list of all the written attractions. And this would work for any city, country in the world. So there are limitations to our model. So for example, the API limits. So the API has usage limits. We cannot make too many requests in a certain time period. That's why also our app is pretty slow, because this can potentially limit the use of the app and require additional fees. There's also technical limitations, because the app may require a high degree of technical skills to maintain, develop, and update over the time, and limited customization and scope. The app may not be able to provide highly customized routes. For example, we may not be able to suggest scenic routes or avoid certain types of roads, or create routes for users that are using other types of transportation. Also with the weather, traffic congestion, we cannot put that all in the same app. And this is also because of which is Python. And there are thank you.
Congratulations. Don't forget to unmute yourself. Mano. And Eduardo. Hey.
I'm waiting for the version 2, Mano, with the clubs.
Soon.
Congratulations, team. Wagner, mute yourself. Congratulations, team. I'm very proud of you. And last but not least, I hope you had a good travel, because now we're ending with the sound of the bird with Thales. Are you ready?
Yes, we are. Let me just share my screen
Ready
here.
to roll.
Ready to roll. So, welcome to Hungry Birds Classification 2. This was a project that was done with Valentina and Rodolphe and all the team behind Le Wagon. And the question that we wanted to answer is, can a computer identify a species of birds based on the sound it makes? Short answer, yes. But to give a little bit of context, in the world, 1 out of 8 species are actually in threat of extinction. And Brazil is actually the 2nd worst country in that list. There's more than 1,000 of vulnerable species here. And the most important thing to know if a species is actually vulnerable or not is to measure its population. And the traditional way of doing it is actually to send a team of researchers in the middle of a jungle in a very remote area. And they spend weeks there. It's time consuming, it's labor intensive, it's dangerous. So can we improve it in some fashion? And yes, with what's known as bioacoustic monitoring, we can run the audio through a model and identify the birds based on the recordings. So about our data, we have over 16,000 different samples. To give some idea, this is more than 116 hours of birds singing, more than 80 gigabytes across 121 different species. We use Zenocanto dataset that is available to everyone and is very active. There's more than 6,000 recordings being fed to it every year. The recordings are actually in a somewhat very good quality, and it's uploaded by every bird lover everywhere around the world. So for this project, we focus our efforts within the Brazilian coastline. This is like what we call the Mata Atlântica. and it's actually a very endangered ecosystem. So it was very nice to work with it. But to go to the tool itself, the workflow is that you put input WAV file. Let me just upload a file just so we can actually see what's happening. So we upload a file, and the input WAV file is then converted to an image, and we run through a transfer learning with YAMNet model. There is a state-of-the-art model, and then do our final classification with it. So let's just give a few seconds for the internet to load the WAV file, so we can actually see what's going on under the hoods, right? So we got it. So YAMNet model is actually a 3.7 million parameters model. So it's a very dense model, very state-of-the-art, and it's the heart of Hungry Birds. So we have then a WAV file. There's this graph over here, but a computer cannot classify very well raw audio files. So in order to do that, we actually convert it to an image, which is called a mouse spectrogram. And as you can see, every time the bird's vocalizing, it leaves a mark on the spectrogram. And this is what the model is actually looking for, this kind of pattern. And if we compare across different species, we can realize that the trend is actually very similar and very different from species to species. So this is what the model is actually looking for. It's looking for trends, it's looking for similarities, and comparing to what it knows beforehand. So I think we can jump straight to the tool itself. Let's upload an audio real quickly here. Potentially it's gonna take a few seconds. So just if you guys can stick with me, because actually this is probably quite a long file to load, but we are getting there. Almost. And we're done. So can you guys recognize this one? Maybe a few of you guys can. This is actually a very common bird. So if you make a prediction, the model is gonna give us back, it's an owl. It's a common owl that we have here in the southeast part of Brazil. And the model could actually predict it with over 40% accuracy. So it's actually very certain that this is the bird that it's in the file. And we can even try with a different one. This is what we call a blue mannequin. Let's see if it loads a bit faster. But the thing about this bird, as we are gonna hear it, it doesn't have the most beautiful vocalizing ever, but you will be surprised when you actually see it, because it's a very, very fancy species. So just give it a few seconds for the internet to load. Come on. It's going. Anytime now. And we're good. So this is the guy. Like, it's a very standard bird, like nothing special about it, right? But if we actually make the prediction and understand what's behind this vocalizing, it's this amazing blue bird with a yellow crown. And the model is actually 71% sure that it's this species. So we are very proud of what we could accomplish. There's definitely a lot to improve upon. But the tool itself is very user-friendly. Everybody can use it. You can learn a lot from doing that, from your surroundings. And I would like to thank everyone for listening to the songs, and especially Valentina and Rodolphe and everyone in Levagon that worked really hard during this project. So big round of applause to them. That's it.
Hey, my God. Hey!
Congratulations,
Hey.
team. Great work.
Bandeira maluca. Yeah. Thank you,
Amazing work.
guys.
Yeah, just a reminder for whoever is watching on YouTube or even on Zoom, if you don't know about it, all of these projects is a lot of work, many hours of studying, trying again, coding, testing is not working. You have to go back to the beginning, testing it. So again, congratulations to all of you. I hope you're proud of all the hard work. It was a pleasure to have you as a class. And thank you so much to all of you. Like, I'm talking in the name of all the teachers, all the teacher assistants, Amanda, Andrea, Lucas. It was amazing to have you here. Congratulations to the teachers too. Teachers are the best thing at Le Wagon. Our favorite thing at Le Wagon. The teachers and teacher assistants, you will be missed after the bootcamp when you will not have the teachers to help you on any ticket. Again, congratulations, batch 1144. Now it's time to celebrate. For the YouTube chat, for the YouTube people who are watching, it's not the end for you. We give you a 10 minutes break, 15 minutes break until the next demo day happening at 6 p.m. If you want to see our web development students projects, it's happening on YouTube too. You just have to click on Le Wagon Brasil channel and you will find the YouTube live, and we'll start in 15 minutes. So enjoy this break to go to the bathroom, have a break, and we'll meet again soon. And again, congratulations to these beautiful people for graduating today. It's only the start of a new adventure. Congratulations to all of you. Just me clapping. Thank you, team. Thank you, YouTube Live.